Have you ever been woodworking, screwing things, or drilling holes in your wall with your cordless power drill and wondered, how does this power appliance even work? Well, I sure have. Today, I will be concisely describing the composition and the inner workings in relation to the motor effect and Faraday and Lenz's law, the functionality of a drill. However, before that, let's understand what makes a drill, its structural integrity and components. A normal cordless power drill, as seen on the screen, consists and utilizes very similar components. As you can see, all the diagrams in the screen all share similar apparatus or build. They all consist of a battery slot, switch, gear switch, torque control/adjustment, clutch, gearbox, and a chuck. Some drills have specific parts to them, such as LED lights. However, they serve specific purposes which are not affected by the practical functionality of an everyday drill, so they will not be discussed. Firstly, the gearbox. The cordless power drill uses a planetary gearbox, which consists of a series of planetary gears. These gears are able to produce a lot of torque because the load is shared among multiple planet gears. They are controlled by a main part, called the sun gear. It sits along the middle side of the planet carriers, allowing the gears to rotate smoothly. This is supported by the outer ring. The planetary gearbox are all connected to the mainframe through the transmission and the wires. The control of these are given to the switch, which is the part that we are most familiar with. The switch is a simple design which provides counteractivity whilst pushing, essentially providing a sense of control and balance. As if it was a simple on and off switch, the pressure-sensitive spring-like feeling wouldn't be present. The switch is able to pressure control the rotational index. This is possible through the trigger's rotational cycle or the duty cycle. The trigger controls the driving voltage from the DC battery, in assistance with the transistor and the motor. The trigger is then able to channel the voltage through the spring-based system of the switch. The aforementioned DC battery is a major component of the drill. It is the main source of the power, able to convert chemical energy into electrical and mechanical energy. The battery can be composed in 3 different ways. It can be a nickel metal hydride battery, a nickel cadmium battery, or it can be lithium ion based. The battery works in relation with the PWM, or the pulsed width modulation controller, which uses a wave of fired frequency to transmit power to the motor. This allows different voltage drills to utilize the aforementioned duty cycles, allowing for ease of use and allows for a better size. Going from this, let's delve into the most major component, which is the DC motor. The DC motor allows the electrical energy from the battery to be converted into mechanical energy. The driver motor is the major part of the rotational force. The motor can be either brushless or brushed. However, most of the cordless drills now are brushless, as they provide higher power and runtime whilst also controlling the manufacturing cost. The brushless motor allows the user of the drill to have more control over the rotations, as it integrates electronic circuitry which counteracts imbalance caused by other forces acting through the drill. The universal DC motor contains parts within it, essentially acting as an electrical component box. The rotor of the DC motor contains a core made of metal with copper windings which allow it to connect to the commutators. Since I've talked about brushless motors, since they're more widely used, I will quickly run through brushed motors. They basically use a stepper motor which allows different voltages to be transferred, and they use resistors instead of transistors in the brushless motors. Finally, let's talk about the clutch. It allows movement for the driver head, which is activated when a larger than required torque is applied. The springs of the clutch allows the tension to adjust and allows for the higher torque to pass through. The collar, which is present close to the clutch, allows to regulate the slip of the clutch whilst it's working against the torque. Now that we understand all the components that make up a drill, how does the drill function? Well, the parts connect in surprisingly simple ways, utilizing molding, screws, nuts, bearings, and other simple assembly parts. These assembly parts allow for the inconvenience which may be caused by the jamming and the trigger sticking to be counteracted. The assembly parts allow the different components to connect effortlessly, whilst also providing different benefits, especially against the heating as a result of Lenz's law and the general motor effect. The motor effect states that the physical phenomenon where a current-carrying conductor in an external magnetic field experiences a magnetic force due to the interaction between the magnetic fields. This is related to both the current carrying wires present throughout the inside of the drill, as well as the electromagnet field that is created in the DC motor by the rotor. The rotor forms an electromagnet with the two north and south poles, which line up to the contacts when a current is induced. The electromagnet is aligned at a perpendicular to the stator, which when induced upon creates half a loop and a stop, this resulting in a magnetic flux loop. This is another reason why the rotor and the DC metal coatings are made of iron, as the flux is more transmissible this way. This is directly relatable to Lenz's law of conservation, where the torque vector opposes the magnetic field and the flux created. The energy is then also transferred into heat energy, which is rebutted by the assembly parts created not to burn when heat is produced. The DC motor's production of this field allows it to be the integral center of the drill, leaving it as both the receiver of the energy from the battery through the wires and the rotational control of the drill to the chuck. The switch is then connected to the motor to allow the electromagnet creation through the simple current-carrying wires, the same as the ones connected to the battery. Due to this, all the parts fit in easily with one another and are able to simply work as a DC power applicant. And now, we understand how the different parts of a drill work together and the functionality of it. So next time you're woodworking, drilling holes in your wall, or screwing things, you can understand how the appliance that you're using works.